2.1, solving linear systems by the Echelon method. You've already solved systems before. You've done it a lot in algebra class. You did solving by graphing, solving by substitution, solving by elimination. You already know how to solve these problems, but not by this method. Okay, so make sure you're focused on what the Echelon method is and make sure you're following and doing that. So when we have two equations and two variables, we know that there are three things that can happen. We see two lines that cross, and when they cross, we know that there's one solution. There's one solution at that point, the point of intersection. If we have two lines that are parallel and don't cross, we would say no solution or zero solutions if you want. And also that system is called inconsistent. So that's new. You probably haven't seen that word before, but an inconsistent system is one that leads to no solution. And then the other example that we've seen before is when you actually had two equations that turned into the same line. Okay, and so every point on both lines coincides, right? The point on the red coincides with the point on the blue. So there were many solutions is what we said. Okay, so we probably said many solutions in algebra class, and we're done with it. Now today, that's not going to be good enough. We're going to have to go one step further than just saying many solutions. We'll do more. And then when that happens, the system is called dependent. The Echelon method process works by producing equivalent systems. Another way of thinking about that is trying to reduce those equations. So if you look at this equation and you notice that all of those numbers are divisible by 5, think about if you divide them all by 5. 2x plus 6y equals 5. We can reduce one equation into another equation. They're still the same thing. If you graphed them, it'd be the exact same line, the exact same set of points. Okay, but it's going to be nicer for us and easier for us with the reduced or smaller equations. We're going to use something called row operations. And row operations are like the rules of the game. It's the things that you're allowed to do. So we are allowed to exchange rows, and we are allowed to multiply by a non-zero number. So really, there's no such thing as division. Okay, so a minute ago when I said you divide by 5, technically we should have said multiply by 1/5, but everybody knows what I mean when I say divide by 5 there, or in this example it says multiplying by 1/2 is the same thing as dividing by 2. Okay, so technically we're calling it multiplication, but realistically you're probably dividing. Number 3 is the hard one. Replace an equation with a multiple of itself plus a multiple of another equation. All right, that's pretty tough. Okay, and that's the one that you're going to get stuck on a little bit if you're not paying attention. How to solve a system of equations by the Echelon method. Use row operations, so those 3 rules right there, to produce triangular form, and then use back substitution to find the values. Okay, so triangular form. What we start with is this, but what we want is this. See how those variables form a triangle? Okay, we're trying to turn whatever we started with into a triangle. Okay, we're trying to produce triangular form. And so what you would notice is that whatever the variables were that were right there, I've gotten rid of those. I've disappeared those variables. And that's kind of the main event. That's what we have to do. And then back substitution is pretty easy to understand, because if you look at that, if you look over here, it's pretty easy to see, well, divide by -2 and you're going to get z equals 1/2. So then you would just take that 1/2 and plug it into the equation above, and then you can find what y equals. And then once you find that, you plug them both into the equation on the top, and you can find what x equals. So that's, I think people understand that step, but how to get that triangular form, that's what people really struggle with. So let's do a couple of examples of row operations real quick before we move on. All right, row operations. If I said Don't turn the page yet. I'm not done. Okay. Look at this as being row 1, and this equation is row 2, and this equation is row 3. All right. Think about if I said I want to do row 1 plus row 2. All right. If I gave you the rule and I said I want to do row 1 plus row 2, all you do is add the corresponding parts. So we could say x plus 2x is 3x, and 2y plus y is 3y. Negative 4z plus negative 6z is negative 10z. And 5 plus 8 is 13. That's what I mean by row operations. Now, there's a little bit more to it because you'll have to figure out what the rule is, all right? But that's basically what I mean. So if I was going to do, let's do another one. Let's do row 3 minus row 2. So think about if I did row 3 minus row 2. Okay. Row 3 would be 4x minus 2x is 2x. And negative y minus y is going to be negative 2y. Okay, next one. Negative 12z minus negative. And here's where you run into problems when you have to subtract a negative in your head. So feel free to use a calculator. Use a calculator with parentheses. Type in everything. Okay, negative 12 minus negative 6 is going to be plus 6. Negative 12 plus 6 would give me minus 6z right there. And then 13 minus 8 is 5. Okay, so those are the row operations. That's the kind of thing that we're going to need to do once we get there.